Okay, explore number 5, describing populations. The essential question: how are age structures created? So we're continuing to look at different demographic sort of measures, and we're going to be looking at age pyramids now, also known as age structure diagrams. So go ahead and write down that essential question and write down what you know or think. Go ahead and hit pause for just a minute there. Okay, hopefully you paused the video and you wrote down what you know. So, Roman numeral 1, age structure diagrams, also known as age pyramids. Basically, they're going to show you the distribution of a population based on age, how many people are 0 to 10, 10 to 20, 20 to 30, 30 to 40, all the way up, right, to the oldest people in the population. It also is going to show you the number of males versus females for each of those categories. And all of this information, of course, is very useful in making predictions about the future of a population. Okay. We can use these age structure diagrams to figure out if a population is growing. So you think about, being here in the United States. Is the United States population really growing? Is it shrinking, or is it remaining relatively constant? So you would take census data, and you would use that census data to arrive at these conclusions. Okay, so the first type that we have here, letter A, you can see it says age structure diagram, and it says exponential. I've highlighted that there, and it looks like a J curve. You can see that it kind of starts low, and then there seems to be this kind of swoop up like a J shape. Now, this is not per se an exponential graph, okay, but it does kind of look like that. If you look down at the lowest ages here, 0, 10, 20, you can see that we've got some pretty large numbers there, right? As a percent of the total population, you may say that you have 9% male who are in that perhaps 0 to 5 age, and you have about 9% females, 50-50, who are in the 0 to 5 range. 9 plus 9 is 18%. So you can kind of get this, you can add up these numbers, and you can kind of get an idea of the percentage of, uh, uh, of each cohort. So this really broad base down here can suggest to us that eventually that population is going to start reproducing, right? Eventually they're going to have kids. And so what is that going to look like for the future population size? It's probably going to grow, right, for that country or that whatever it is. So, and you can see here in red, high proportion of young individuals soon will be having kids and contributing to population size. Males are on the left-hand side. That's what this left graph is. And females are here on the right-hand side. Okay, let's take a look at graph B. This graph is a little different. Let's see if I can try to click these things without moving them all. And this one says that the population is declining. Okay, so why would we say, just looking at B, why would we say that this is declining, getting smaller? The reason why is if you take a look at the youngest population, the non-reproducing population, let's say 0 to 12 or 13, somewhere around there, their numbers are relatively small compared to the next group up. The next group is circled in purple. This would be your, say, 15, 17-year-olds all the way up to maybe we could say up to 40. Okay, see how much they're a little bit wider as far as a percent of the population. More people are here, fewer people are down here. That if you have a smaller group of young people, eventually that small group, when they get to reproducing, having kids of their own, they're not going to contribute as many people to the population. So over time, we're going to see a decrease in the size of the population. We see this in countries like Japan right now. We see it in countries like Russia right now. Okay. Now, so hopefully, as you take a look at things in general, you're saying, well, yeah, that definitely looks different. The first exponential one kind of looked like a broad-based, maybe pyramid. And this one here kind of looks more like some weird helmet. Let's take a look at picture C. I don't know, I keep on pressing these buttons and messing things up there. I'm trying not to. Okay, so picture C, it shows us a stationary age structure diagram. This is basically saying that your population size is going to remain more or less static, unchanged. And at first glance, you may say, well, the bottom looks kind of fat. Shouldn't they cause the population to increase? And remember, you got to add the numbers and compare them. So 0 to maybe 13 years of age or 15 years of age, compared to the 15 to 40-year-old group, those numbers actually, even though it kind of looks a little different, you have quite a few people in this purple circle, about the same number of people as you have down here. So that just suggests to us that you're going to have relatively equal numbers of people dying as who are born in a population. And so we're not going to see too much of a change, not going to decrease and not going to increase. Okay. So, and I encourage you just to kind of read in your text a little bit just to try to get a good grasp of that. So as you can see here in black, this is going to be approximately equal, these two populations. Therefore, the overall population size will remain stable over time. Okay. All right. So if we kind of come down a little bit, you can see there's something off to the left here. Oh, let's not do that. Keep on doing that, huh? Okay, so here we go. What does it say over here? We use these age structure diagrams to make predictions about future populations. Okay, that's all I had written off there to the side there. Okay, so I'm going to keep on moving here. Other factors. This is important. Let's go ahead and reduce this just a little bit so you can see this a little bit better. Other factors such as reproductive rate can affect your population size. Okay, what do we mean when we say reproductive rate? Well, that's the average number of kids that people have. Do people in America, for example, have on average only one child? Maybe you come from a family and you're an only child. Maybe you come from a family with more than one child. On average, how many kids does the average family have in America? If it is, in fact, one, then this will result in a stable population size. If people on average have fewer than one child, this is going to result in a decrease in the population size. And finally, if people on average have more than one child, then this is going to result in an increase in population size. Okay, so there's that for your consideration for you to think about. Okay, so let's go ahead and do this. Let's just kind of scroll through our text really quickly. You can see that I borrowed those graphics from your text there. And they kind of go into detail on some of the things that I was highlighting there with you. And just reduce this. Actually, what I'm going to do is just I'm going to open this up all the way here for a second. And just get this up to a normal size so you can see that. All right, so why don't you go ahead and hit pause and write your summary paragraph, and we'll go ahead and talk to you guys soon. All right, take care.